testing of DC machines. Direct method brake test. In direct method, the DC machine is subjected to rated load and the entire output power is wasted. Brake test is the direct method of testing small DC machines. The experimental setup for performing brake test on a DC shunt motor is shown on the screen. It shows the belt and pulley arrangement mounted on the shaft of the motor. In the brake test method, the motor is subjected to a direct load by means of a belt and pulley arrangement as shown in the above figure. Connect the circuit diagram as shown. The field regulator RSH should be kept at minimum resistance value. If there is no load on the pulley, then the belt on the pulley will be free. Use the starter to start the motor. The field current should be adjusted so that the motor runs at its rated speed. Load should be applied slowly in steps, keeping the belt tight. Take the readings of the ammeter and voltmeter connected to the motor. Take the readings of the two spring balances and record the speed at every step. The pulley should be cooled during this loading period by pouring some water. Repeat the experiment till full load of the motor is reached. The load should be applied slowly by adjusting the tension of belt with the help of pulley. We can observe that there will be a decrease in the speed of the motor. Full load current can be recorded by adjusting the load. The power waste due to the friction between belt and shaft can be estimated through the readings of voltmeter and ammeter. We can test the motor by applying direct load so that we can analyze the motor for its behavior for various loading conditions. Example, heating of the motor, current and voltage rating, losses in the motor, etc. The name brake test is given due to the braking action of belt. The tension in kilograms can be obtained from the spring balance readings, which can be adjusted using the handle. Let R is equal to radius of pulley in meters, N is equal to speed in RPM, W1 is equal to spring balance reading on tight side in kilograms, W2 is equal to spring balance reading on slack side in kilograms. The output power and efficiency through this test are derived as follows. The output power and efficiency through this test are derived as follows. Advantages and disadvantages. Advantages. Brake test gives actual efficiency of the motor under working conditions. Brake test is simple and easy to perform. It can be performed on any type of DC motor. Disadvantages. Due to friction, heat generated and hence there is large dissipation of energy. Some type of cooling arrangement is necessary. Convenient only for small machines due to limitations regarding heat dissipation arrangements. The power developed gets wasted, hence the method is expensive. the efficiency observed is on lower side. The spring balance readings are not steady. The friction torque at a particular setting of the springs S1 and S2 does not remain constant. Indirect method of testing DC machines, Swinburne's method. This is a no-load test. It cannot be performed on a DC series motor because the speed of the motor on no load will reach to dangerous speed and leads to damage of the motor. In this method of testing, the machine is run as a no-load shunt motor at rated speed and with rated terminal voltage Vt. The power absorbed by the armature is equal to the no-load rotational loss plus a small amount of armature circuit loss. Make the connections as shown in the circuit diagram. Start the DC motor with the starter slowly and bring it to a rated speed. Take the no-load readings of input current, armature current, field current and input voltage. No-load rotational loss is given by, here armature circuit resistance Ra includes the brush contact resistance also. Shunt field loss is given by, let I1 be the load current at which the machine efficiency is required. Then the expressions for efficiencies of generator and motor are derived as follows. Advantages. The efficiency can be estimated at any load since we know constant losses. Testing of a large motor can be done with less power. Therefore, the method is convenient and economical. The motor is not required to be loaded, that is, only test to be carried out is the no-load test. Disadvantages. In this method, the iron losses are assumed to be constant, which is not the true case as they change from no load to full load. Due to armature reaction at full load, there will be distortion in flux which will increase the iron loss. The only test which is carried out is the no-load test. Hence, it is difficult to know whether there will be satisfactory communication at full load. One cannot find the rise in temperature on rated load. As it is a no-load test, it cannot be performed on a series motor. Stray load losses cannot be obtained. It does not give information about commutation on rated load is satisfactory or not. Regenerative or Hopkinson's method of testing. Hopkinson's test is used to determine the efficiency of both motor and generator which are coupled together. In this method, full load test can be carried out on two identical shunt machines without drawing full power from the means. For this reason, this test is called regenerative or back-to-back test. The two machines are mechanically coupled and one of them operates as motor while the other one operates as a generator. The output of the generator is used to supply a greater part of the motor input. Power taken from supply is utilized to overcome the losses. One of the machines is made to run as a motor and it drives the other machine as a generator. For performing Hopkinson's test, machine 1 is started as a DC shunt motor by a starter and brought up to the rated speed with switch K open. field rheostat is used to adjust the speed of the motor. Both the machines 1 and 2 run at the same speed because they are mechanically coupled through shaft. The field current I3 is now adjusted, and when the voltmeter across the switch K reads 0, then switch is to be closed. Note: the 0 reading of the voltmeter will indicate that the generator voltage has the same magnitude and polarity as that of the supply voltage. This will prevent heavy circulating current flowing in the local loop of armatures on closing the switch. The magnitude of the armature currents and I2 can be adjusted to any value by varying the field currents I4 and I3. The machine with a lower value of field current runs as a motor. Note: the counter EMF would be less than the EMF generated in the armature of the other machine. Hence, the machine will be acting as a motor. The machine with a higher field current runs as a generator. By adjusting field rheostats of motor and generator, R1 for motor and R2 for generator, different ammeter and voltmeter readings will be obtained. Since both the machines are coupled electrically, the power output of generator is fed to the motor, and it is for this reason that Hopkinson's method is called a regenerative method. Make the connection as shown in the circuit diagram. Keep the rheostat in motor field at minimum and generator field at maximum resistance position and switch K open. Start the motor generator set slowly with motor starter and adjust the field to rated value by field rheostat of the motor. Excite the generator by decreasing the generator field rheostat resistance. If the voltmeter reads 0, then close the paralleling switch K. Load the generator in steps by decreasing the field rheostat resistance of the generator or by increasing the field rheostat resistance of the motor. Reduce the excitation of the generator by increasing the field rheostat of the generator and open the switch K. Let V is equal to supply voltage. I1 is equal to current taken from the supply. I2 is equal to current supplied by generator. I3 is equal to exciting current of generator. I4 is equal to exciting current of motor. RA is equal to resistance of armature of each machine. Nu is equal to efficiency of both generator and motor. Then efficiency of the motor is calculated as follows. Advantages. The various advantages of Hopkinson's test are: the method can be used for large-size machines because the power drawn from the DC source has to furnish only the losses in the two machines. The machines can be tested under rated load conditions, and thus the temperature rise and commutation process can be checked. The efficiency is being determined under rated load conditions, therefore the stray load losses are included. Disadvantages. The various disadvantages of Hopkinson's test are: difficult to get two identical machines. The iron losses are different in both the machines because of different excitations and cannot be separated. It is difficult to analyze if the two machines are small machines, as they may not be loaded equally. The test is best suited for large machines.